This vlog will be analysing performance in the 505 agility drill, whereby the athlete takes a 10-metre run-up and is then timed over a 5-metre shuttle. When the athlete initially performs the drill, they seem to struggle with the eccentric force absorption requirements of the drill and the technical capacity of staying low in the turn. This results in a relatively high body angle in the re-acceleration phase and thus relatively poor acceleration mechanics. In order to improve these force absorption capacities, some basic single leg plyometric exercises can be used. These could be made more specific to the drill by doing them laterally. Firstly, in a relatively controlled environment, bilaterally. Then in a less controlled and more physically demanding environment, unilaterally. Breaking down aspects of the actual drill itself is also a useful training tactic, in this case using 2.5 and 1.5 meter decelerations to practice the eccentric force absorption required in the 505 drill. After focusing purely on force absorption, this can be progressed with force absorption to production drills, utilizing quick plyometric drills, with unilateral drills being the primary focus. Fast eccentric force absorption in the posterior chain is also an important capacity to improve, from both an injury prevention and performance enhancement perspective. Progressing these rapid eccentric force absorption and production drills can be done through increasing the speed of the drills and by changing them from bilateral to unilateral exercises, thus making them more specific to the test at hand. Once some of the physical capacity requirements have been addressed, some of the technical aspects of the drill can be focused on. For this athlete, this largely revolved around breaking the skill down in terms of slowing it down and ensuring correct technique was used in the approach to the change of direction and the acceleration phase following the change of direction. Physical cues such as touching the ground were used to ensure the athlete get low in the change of direction, and verbal cues such as to cut the grass and push the earth back were used to ensure correct acceleration technique and proper frontside mechanics during the acceleration phase. Other aggressive drills include simplifying the physical and technical requirements of the drill by reducing the cut angle to 45-degree cuts, 90-degree cuts, and 135-degree cuts, rather than the more demanding 180-degree cut of the 505 test itself. When re-attempting the drill, the athlete is able to get much lower in the turn and thus able to produce greater force in the re-acceleration phase with better technique, cutting the grass and pushing the earth back, thus reducing an overemphasis of frontside mechanics. This allows the athlete to attain and maintain a much lower angle during the re-acceleration phase. This is most evident when directly comparing before and after the training period the athlete's performance, whereby beforehand the athlete is much higher in their approach to the change of direction. The physical cue of being able to touch the ground was extremely useful for this athlete to maintain this low position. Meanwhile, from the side view, we can see the athlete is much more confident approaching the change of direction at speed. The low centre of mass shown on the right hand side allows the athlete to maintain balance at foot contact. This also permits for a much more favourable position at toe off of the acceleration phase. As we can see, this carries through to the first step of the acceleration phase, whereby the athlete is much better positioned for acceleration. To summarise, this athlete focused on unilateral eccentric force absorption in both separate and related drills. Then, breaking down the 505 technique itself, focused on the technical aspects of the change of direction and acceleration phases of the drill. Improvement here was largely achieved through both physical and technical cues.